In this video, I'm going to talk about how we're going to use the unit circle and really just kind of part of the unit circle to help you find the trig ratio or trig function for any single angle around the unit circle. And I'll show you kind of the process here, but really get into it with the next lesson. So it's kind of just kind of the workup or the warm up to the most important lesson, which is the next one. So just this idea of a unit circle. So key takeaway from the unit circle is that the center is 0, 0, and the radius is 1. If that's true, then if you look at these kind of the first two images here, you'll notice they're using an angle t, or I'll just say angle theta. And if you have that unit circle, you know it is a unit circle, then the coordinates for x and y actually end up being the same as the cosine of your theta for the x, and the y value is the same as the sine of your theta. So it's something that we'll kind of memorize for the quadrantals, and I'll show you at the end a unit circle. I don't memorize that. I'll show you the way that I kind of go about doing this, but that's really where this is coming from. You'll see that image at the end. Okay, so let's first talk about defining the sine and cosine functions from the unit circle. So this first one, looking at the input, is the measure of the angle. All right, we're talking about the sine function. And the output is the y coordinate. So if you are given a unit circle or something about the coordinates, you can always look at the y value and know that matches up to the sine. All right, in terms of cosine, it's always about the x value. All right, and we're talking about the arc of length t, which is just our angle theta. All right, so the cosine is equal to the input or the x value. Okay, now let's talk about how we're going to use this to help us find some of these trig functions. So if you look at this example here, theta or t is going into the second quadrant. So we have an initial side, right, of this side here from our last lesson. We're going around in a counterclockwise direction. So this means our angle theta or t is positive. All right. And then it's giving us the ordered pairs right here of x and y. And essentially, this is telling you for x, that's the cosine of angle t or theta, is negative square root of 2 over 2. And the sine of angle t or theta is the y value, square root of 2 over 2. All right, now you're going to see later on how we can actually figure out what this angle theta is. All right, looking at something called the reference angle. So that's the distance from this terminal side to the nearest x-axis. So this distance is called the reference angle. And if you look at the sine and the cosine, they're both the square root of 2 over 2. And that means this reference angle must be 45 degrees. Okay, because the sine and cosine of 45 degrees is both the square root of 2 over 2. Now, when I look at finding my angle theta, if I'm backing up from 180 degrees, if I do 180 degrees minus 45 degrees, I would find that my angle t is 180 minus 45 degrees, which is going to be 135 degrees. Now, you may be wondering why one is positive and one is negative, and I'll get into this later on in the lesson, but I just want to show you here how this relates. If you know your quadrants, right, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And if you remember the acronym, all students take classes, all right, this A stands for all of the trig ratios are positive. For S, this is for sine and its reciprocal, which we'll get into next lesson, cosecant. T stands for tangent and its reciprocal, cotangent. And then finally, C stands for cosine and its reciprocal, secant. So those are positive in those respective quadrants. So in this case, if you look, we're in the second quadrant. So in the second quadrant, our sine of our angle theta is positive, but our cosine is negative. So that's how they get all this to kind of come together. Okay, let's do some examples with quadrantals. So I'm going to sketch this. So we have 90 degrees. So we're starting with our x-axis here, and they're both positive 90. So I'm going to rotate counterclockwise to get to this positive y-axis. And so this is 90 degrees. Now, for quadrantals, there's always going to be that ordered pair that I worry about or that I memorize, and that ordered pair from a unit circle is 0, comma 1. And if you understand this part of the unit circle, remember the x-coordinate represents the cosine of that angle. So the cosine of 90 degrees is the x-coordinate of 0, and the y-coordinate of 1 corresponds to the sine of this angle, so the sine of 90 degrees is 1. So that's how I use the unit circle for quadrantals. Let's do another quadrantal. This time we actually have a radian angle measure of pi. So I'm going to start with my initial side. I'm going to move counterclockwise, and pi actually gets all the way to this other part of the x-axis. All right, so this is the angle pi. All right, and that ordered pair is going to be -1, comma 0. So again, knowing the unit circle, that if I know it's a unit circle, then my coordinates, my x corresponds to my cosine of my theta, and my sine corresponds to the sine, or the y value corresponds to the sine of my theta. So the cosine of pi is equal to the x-coordinate of -1, and the sine of pi is equal to the y-coordinate of 0. So always kind of take that understanding, and you'll see it later on. But as I said, I really just use this for the quadrantals, and I use this kind of whole thing I talked about in this previous example to find any other angles. Okay, let's take a brief pause on like the special angles, which we're going to come back to and are the most important. But let me show you what happens when we just have a sine of some theta giving us a ratio. So if I draw a sketch here, if I drew a sketch, all right, it says we're the second quadrant. So I'm going to start on the initial side and draw to the second quadrant. So here is my angle theta. And then if I were to make a triangle out of this, so make a triangle, all right, a right triangle to be specific, all right, and I looked at this being my x value, this being my y value, and then this we're going to use is my hypotenuse, and I'm just going to use as r, but you can use any letter you want. But the key thing you need to know is that the hypotenuse, whatever letter you end up using, is always going to be positive, okay? So this is saying that the sine of our angle T is equal to 3/7. Now, if you go back to your days in geometry, you should hopefully remember with right triangles, you have SOH, CA, TOA, right? So if we're talking about the sine of an angle, right, of this theta, the sine is going to be equal to the opposite side over the hypotenuse. So this is equal to the opposite side over the hypotenuse. Or if I'm using my letters for my triangle, the opposite side is y, and the hypotenuse is 7. So I'm going to replace y is 3, and r is 7. Now, r, or the hypotenuse, is always positive, but take a moment and check, all right, does this make sense to say this y value is a positive 3? Yes, it does. We're moving up in the y direction. So now, if I wanted to find my x value, I could use Pythagorean theorem, right? So if I use y squared, let me just go in order, I guess. X squared plus y squared equals r squared. I could figure out what that value for x could be. So x squared plus 3 squared equals 7 squared. So that's going to be x squared. Skip a step here, right? 49 is 7 squared. 3 squared is 9. Subtract that over was minus 9. So 49 minus 9 is 40. I want to take the square root of that and write the square root of 40. Notice I'm just working with the positive right now. And if you wanted to reduce it, you'd have inside that 40, you have a perfect square of 4 to get 2 times the square root of 10. I'm not that worried if you don't reduce it. But the key thing is when I write it, guys, is that I'm going to write 2 times the square root of 10. But pause for a second. If you look from the origin, right, I'm moving to the left to get to this point up here. So this needs to be a negative. All right, 2 times the square root of 10. So that's a mistake that I see pretty much when there is a mistake in these problems. That's the most common one because students are just thinking, oh, everything's positive. But that may not be the case, right? R is always positive, right? Hypotenuse is always positive, but x and y could be negative. So make sure you're checking based on which quadrant you're in. In this case, the second quadrant means our x value should be negative. So now to get the answer they want, they want the cosine of that angle T, which using SOHCAHTOA again, right, is the adjacent side of negative 2 times the square root of 10 over the hypotenuse of 7. All right, so that's kind of how I view these types of questions. And the key thing I would say is make sure you do a sketch. That's going to help you hopefully sort out what you're missing and how to find it. Let's do the same thing with another example, this time in the fourth quadrant. So now I'm going to go in the fourth quadrant. So I'm starting here in the x-axis, going all the way around in the fourth quadrant to there, making my triangle, right, my right triangle. There's my point, here's my right angle, here's my theta. And they're telling us that the cosine of t is equal to 24/25. All right, so as we mentioned before, right, we're looking at I should have written this as r, sorry about that. We're looking at this being my x, this being my y, and my hypotenuse being r. Now for cosine, which is adjacent over hypotenuse, that's going to be x over r. So my cosine, or my x value is going to be 24. My r is going to be 25. Take a moment and check. Right, r is always positive, so we're good there. Does it make sense? Moving from the origin to the right, is that a positive? Yes, it is. So we're okay there. So let's find that missing value for y using, like we did before, our Pythagorean theorem. All right, so we're going to do 24 squared plus y squared equals 25 squared. All right, so this is y squared equals, all right, and I'll go ahead and use my calculator for this one because I do not, I actually do know these, but I'm not expecting everyone to, so go ahead and use the calculator. So I'm going to use 25 squared minus 24 squared. So 25 squared minus 24 squared gives me 49. Remember, that's not what I want, right? I want the square root of that, but I know that y squared is going to be 49. So y equals 7. Now be careful. I'm going to write the 7, okay? But let's check and make sure that that makes sense. I'm moving down in the y direction, so I need to make sure that I put negative 7. Okay, so just like over here, I end up needing a negative. Same thing here, I need a negative for my y value. Now, that may not always be the case, but I just want to make sure you take those 10 seconds just to be sure. So now we're trying to find the sine of our angle t, which SOHCAHTOA is opposite over hypotenuse. So here's my theta. So opposite over hypotenuse is going to give me negative 7/25. All right, now just for a pause for a second, you'll notice that both of these answers end up being negative. If you go back to my quick little explanation about all students take classes here, you can kind of see why this makes sense. We're in the second quadrant in this example, right? So in the second quadrant, that's S for sine and cosecant. So cosine will be negative, hence my answer. And in this one, I was in the fourth quadrant where it's C for classes. So cosine and secant are positive, not sine, which is why sine was negative. So again, you don't have to know that to get this right, but just kind of another reminder that everything is related that we're doing. Okay, let's get to the special angles. So these special angles, 30 degrees, 45 degrees, 60 degrees, they've got a bunch of figures here to help you prove it. I'm not concerned about the proof. I'm concerned about you memorizing the sine, cosine, and tangent of all these, and we will be having a small quiz, small summative, to make sure you have this memorized. So let's make a quick table that you're going to end up memorizing. So I'm going to write sine, cosine, and tangent here. And up here, I'm going to write 30 degrees or pi over 6, and then 45 degrees or pi over 4, and then finally 60 degrees or pi over 3. So the first thing I would say you need to memorize is that 30 degrees is the same as pi over 6 radians. You also need to memorize that 45 degrees is the same as pi over 4 radians, and 60 degrees is the same as pi over 3 radians. The way I memorized in high school was 45 starts with a 4, so my denominator is 4. And then for 30 degrees and 60 degrees, they kind of trade the 3 and the 6. So 30 degrees gets a 6 in the denominator for radians. 60 degrees gets a 3 in the denominator for radians. So here's how you memorize it. All right. The sine of 30 degrees is 1/2. All right. So then the cosine of 60 degrees is 1/2. All right. The cosine of 30 degrees is the square root of 3 over 2. So the sine of 60 degrees is the square root of 3 over 2. All right. So that's kind of the first thing I do. Then for sine and cosine for 45 degrees, they are actually going to be the same. The square root of 2 over 2, which we kind of talked about in the first example on this lesson. Now here's where it gets a little tricky. The tangent of 45 degrees is 1. All right. The tangent of 30 degrees, I think of it like this. 30 degrees starts with a 3, so it's going to get more 3's, so the square root of 3 over 3. And the tangent of 60 degrees is just the square root of 3. All right. 60 does not start with a 3, so it's only going to need 1 3. Or they're going to get 1 3. Okay, so again, this right here, got to memorize it, have to memorize this. All right, you'll be taking a small quiz summative on knowing this table. Okay, if you know that and how to find reference angles and know all students take classes for your quadrants, all right, you should have no trouble being extremely successful on finding the trig ratio for any angles, especially when we get to the next lesson. So these are kind of the two things that I have memorized. I think it's easier to memorize these. I'll skip to it for a moment, right here at the end. I think this is way harder to memorize, right? So I don't memorize this. As I said, I just memorize really just the first quadrants, right? Those special angles in this table. So if you know this table and you know all students take classes and how to find reference angles, those 3 things, you should be good to go. All right, let's show you how to do it then. All right, so cosine of 5 pi over 3. It says using a calculator. We don't need to. We got this without a calculator. So I'm going to draw on my sketch. 5 pi over 3. All right, if you're having trouble about where this ends up, just think about, going all the way around is 2 pi. So if you change that to a denominator of 3, right, that would be 6 pi over 3. So 5 pi over 3 is going to end up in the 4th quadrant. All right, so there is 5 pi over 3. Okay, so the first thing I do is I find my reference angle. The reference angle is the distance from this terminal side to the nearest x-axis, which is actually going to be 2 pi radians. All right, so I use this little fish symbol for the reference angle. Now we're going to practice here in a moment, so I'll show you all the work on that one. But on this one, what I tell my students, and hopefully you'll start to understand this, is that if you're in radians, and I'm being nice to you, which I'm going to be nice to you, right? You'll notice that my angle is 5 pi over 3. So the reference angle is going to be pi over 3. So that's something that I always tell students is just use the denominator to your help. Whatever the denominator is, that's going to tell you what the reference angle is. So now, if I find the cosine of my reference angle of pi over 3, let me write it like this. The cosine of 5 pi over 3 is equal to the cosine of pi over 3. Now pause for a second. Think back to your all students take classes. What quadrant are we in? We are in the 4th quadrant where cosine and its reciprocal secant are positive. So in this case, we're talking about cosine. So actually, I don't even need to make this negative. It's in the 4th quadrant where cosine is positive. So in this case, these are going to be exactly the same. So if you know the cosine of pi over 3, then you actually also know the cosine of 5 pi over 3. It is the same thing. And from our table, the cosine of pi over 3 is 1/2. If you need to refer to the table, right, cosine of pi over 3 is 1/2. Okay, so that's kind of the whole process. Again, it's not really what this lesson is about yet. That's really next lesson, but I want to show you now because the more you practice, the easier it's going to be. Let's try this one, the sine of pi over 3. This is one of those that you can sketch it, right? But guys, the angle pi over 3 is in the 1st quadrant, right? And if it's in the 1st quadrant, my expectation is that you have this memorized. So the sine of pi over 3 is something that you should have memorized, which is the square root of 3 over 2. Again, go to the table if you need to. The sine of pi over 3 is the square root of 3 over 2 from the table. All right, so that's it. Didn't even need to use my all students take classes because it's in my table. Okay, So, as I already kind of mentioned in the first lesson, here it is again, reference angles. We're kind of already talking about it, but again, to find reference angles, you find the distance from the terminal side of your angle, so where it ends up, whatever quadrant it's in, to the nearest x-axis. That's the key thing here, guys, to the nearest x-axis. You can try to memorize all these different formulas they have. Again, it's one of those things that I don't really rely very much. I'm not going to say don't memorize things. I for sure memorize things, right? Like I said, the table. But I'm not going to rely on memorizing this. I'm going to rely on my understanding that the reference angle is the distance from the terminal side to the nearest x-axis. If I know how to do that, I don't need to memorize anything. All right, so let me show you an example in degrees and radians. So here we go. We've got 225 degrees. Again, if you're having trouble about where to draw it, you can always think, okay, this is 0 degrees, this is 180, this is 270. All right, so that's going to be in between 180 and 270. All right, actually halfway in between them, which is 225. Okay, so that's in the third quadrant. Don't actually need to know that it's in the third quadrant, but what that's going to do is show me that the nearest x-axis is actually backing up to 180 degrees. So that distance is my reference angle. So I will show you the work for these two. So it's going to be 225 minus 180. So my reference angle is 45 degrees. Now, just to be clear, guys, let's say you made a mistake and you did 180 minus 225. You get negative 45 degrees. That's okay. Just make it a positive. Reference angles are always positive, acute, and remember, most likely, again, not always, but when I'm asking you to do trig ratios, they're most likely going to be from this table, 30 degrees, 45 degrees, or 60 degrees, or their radian equivalents. All right, you'll start to see that pattern. Let's do the next one. Kind of already did this in the previous problem. That's okay. Let's do 5 pi over 3, and I'll show you the work this time. So we're starting with the x-axis here. Like I said, we've got 0. This is going to be pi over 2, pi, 3 pi over 2, and then all the way around is 2 pi. Change them to be denominators of 3 if you need to. Like I said, I really probably change this to be denominators of 6. Let me do that real fast. So this would really be the same as 10 pi over 6. So this is 3 pi over 6, 6 pi over 6, 9 pi over 6, and what's that going to be? 12 pi over 6. So you should see that 10 pi over 6 is between 9 and 12 pi over 6. So that means I'm going to end up, which you already knew, in the fourth quadrant. Okay? Now, for this one, the nearest x-axis is going to be all the way around, right? 2 pi. So this is going to be my reference angle. So to show my work, I'm going to do 2 pi minus my angle of 5 pi over 3. Now I'm going to go ahead and get a common denominator, right? This is 2 pi over 1. So if I get a common denominator, that's going to be 6 pi over 3 minus 5 pi over 3. So my reference angle is 1 pi over 3. Now, you should not be surprised by this, guys, because, as I said, right, if I'm being nice to you, whatever that denominator is going to show you what the reference angle is. Okay, so that's how you find reference angles. You're going to get a lot of practice on how to do that. All right, let's do one more, really two more examples, but really the same idea, where we evaluate these using reference angles. Okay, so I'm going to draw some sketches here. Let's draw 315 degrees first. So 315 degrees is going to start at 0 degrees. There's 90, 180, 270, and all the way around is 360. So 315 is going to be in the fourth quadrant. All right, find your reference angle, distance from the terminal side to the nearest x-axis, which is going to be our little fishy. So that's going to be 360 minus 315, which is 45 degrees. So now, instead of finding the sine and cosine of 315 degrees, I'm going to find the sine and cosine of 45 degrees. So find the cosine of 315 is really going to be finding the cosine of 45 degrees. And then for the sine of 315, I'm really going to be finding the sine of 45 degrees, which I know from my table that both of these are the square root of 2 over 2. But this is where you have to be careful. You are in the fourth quadrant. So if I'm using all students take classes, the only one that's going to be positive here is cosine. So this one is going to be positive. So that is the answer. But because I'm asking for the sine, this one is going to be negative. So the cosine of 315 degrees is positive, square root of 2 over 2, and the sine of 350 degrees is negative, square root of 2 over 2. All right, let's do all that whole same process, but for negative pi over 6. And this is a good one because with negative, we're going to be moving clockwise. So we have 0 degrees, radians, 0 radians, negative pi over 2, negative pi, negative 3 pi over 2, so you can see it's a little bit different, and negative 2 pi. So now when I draw this, I'm moving, right? I'm going to be moving clockwise, which is only right here, right? That's negative pi over 6. So it's weird because you're thinking, oh, that's the first quadrant, but actually no, because we're moving negatively in a clockwise direction, this means it's actually in the fourth quadrant. So my reference angle is actually pi over 6. So when I find the cosine of negative pi over 6, I'm really finding the cosine of pi over 6, right? And when I find the sine of negative pi over 6, I'm really finding the sine of pi over 6, which I can write right now. The sine of pi over 6 is 1/2. The cosine of pi over 6 is the square root of 3 over 2. Remember, I'm referencing my table, but don't be done yet, right? Don't forget all students take classes. We happen to be in the fourth quadrant again, where cosine is going to be positive. So this one will be positive, but my sine will be negative. Okay, so make sure that you are always checking the all students take classes. And don't worry, you'll have so much practice on this. All right, so that's it. Remember that last little image here. If you want to look at the entire unit circle, that's fine. I don't think it's worth memorizing. Remember the three things. Here they are again. This table here, which we'll have a quiz on, all students take classes, that's the second thing, and then how to find reference angles. You know those three things. You should have no issues finding the trig ratio of any angle. Good luck.